El paper que va a presentar ahora Sofía es Failure Prediction in Automatic Reclosers Using Machine Learning Approaches. Sophia Boing es de Brasil, del CERT Foundation de Florianópolis. Y bueno, te damos la bienvenida, muchas gracias y adelante.
Okay, gracias. So, hi everyone, I am Sophia Righetto. I am electrical engineer at CERT Foundation. CERT is an institution that develops R&D projects under the Brazilian energy regulator, ANEEL. And this paper is a preliminary study of an innovation project in partnership with Enel São Paulo on predictive maintenance in automatic reclosers. So we know that the automatic reclosers is an important equipment in the power distribution system, which currently only receives corrective and preventive maintenance. So through the literature review, we observed that the machine learning methods have been successfully applied to several problems in the electric sector, including asset analysis, detection of deviation in component behavior, and failure prediction in transformer too. So it was clear that the use of machine learning methods aimed at predicting failures in the electrical sector has great potential to be explored. So this paper proposed a preliminary study using ML methods to predict failures in automatic reclosers. So the paper highlights are the proposition of a novel approach for failure predictions in automatic recloser using ML methods, the development and validation of rules to predict failures in automatic recloser based on specialist experience, the benchmarking and performance evaluation of ML methods in a dataset with 3 types of failure. So here we have a diagram with an overview of the proposed approach. We have the automatic recloser installed in the distribution network. This equipment have sensors to monitor their operation, and together with the specialists in the area, we choose 4 sensors to incorporate into the study. Yeah, so the data from the sensors is stored in a data lake at the energy company, Enel platform. So in addition to these 4 sensors, we use data from registration information about the automatic reclosers, specification about models and manufacturers, commissioning dates, information about maintenance activities in the last 3 years, information about the consumer units served per automatic reclosers, priority consumer units, and databases with the recording of the activation and desactivation of these 4 alarms in the last 3 years. So pre-processing approaches were applied in the raw data extracted from the data lake. Features with low variance or with no values were removed from the data files. In addition, standardization and normalization procedures were applied of each column of the data. And given that the assets are exposed to climate change, the ambient temperature can decrease the life cycle of automatic recloser. Yeah, so temperature data were collected by a web crawling process using the geographical position of each automatic recloser. So the thermal amplitude information were calculated with data, and this information was also integrated to the data set. Yeah, so then we applied the business rules in this data set, yeah, and investigate which of the 5 machine learning methods would be better at predicting failures in the automatic recloser. So we investigate naive Bayes, deep neural network, decision tree, gradient boosted tree, and random forest. Okay, this is the business rules. So with these 4 alarms of the automatic recloser, 74TC, 74CC, BXTB, and FLCA. We apply this following business rules. So if the 740C alarm stays active for more than 1 minute, it indicates that there will be a failure in the opening coil of the switch. And if the 74CC alarm has been active for more than 1 hour, it indicates that there will be a failure in the closing coil of the switch. And the third rule, if the BXTB alarm is active for more than 1 hour, while the FLCA alarm is off, it indicates that there will be a failure in the battery of the automatic recloser. So we have the evaluation metrics. And since the machine learning methods proposed in this study perform binary classification, 0 or 1, and the data set is imbalanced, it was used the F1 score to evaluate them. Yeah, defined in the equation 3. And this metric is composed by the precision and the recall, defined in the equations 1 and 2. So the true positive indicates the amount of correct classification of the class 1. True negative indicates the amount of correct classification of the class 0. False positive indicates the number of wrong classification of the class 1. And false negative indicates the number of wrong classification of the class 0. So, results and analysis. And in this experiment, the dataset contains 445 samples, 339 of which are class 0, no failure, and 106 of class 1, failure. So the dataset was split using holdouts method for training, validation, and test subsets. The proportion was 60% to training and validation subsets and 40% for the test set. The tenfold cross-validation methods was used to train and validation ML methods. This table presents the results of the F1 score metrics obtained by the ML methods in the validation and the test set. So the F1 score results show that the naive Bayes and the DNN methods had the worst results compared to the others approach, so possibly caused by overfitting. The DT, decision tree methods, obtained slightly better results on average compared to the previous methods. However, the test result was random. The gradient boosted tree methods obtained more satisfactory results compared to previous approach, with an average of 67.74% in the test set. The best result of the test set was obtained with the random forest methods, equals to 82.47%. So in this way, the results indicate that the ensemble methods, GBT and random forest, are the most appropriate approach to this problem due to the ability to learn with few data samples and in a scenario of imbalanced classes. On the other hand, the results of naive Bayes, decision tree, and deep neural network indicated a great sensitivity to distribution and amount of data. Yeah, so here we have more results and analysis. In these figures, the confusion metrics of each machine learning methods are presented in a heat map plot with the test set results. So the y-axis predicted represents the model inference, which is the sample predictions as normal or failure, 0 or 1. The x-axis class represents the real events in the field, if the samples were in a normal or failure state. So in the figure A shows an overfitting behavior on the naive Bayes method, where all predictions were classified as no failure. In the figure B and C, the DNN and the DT methods showed a behavior practically similar to the NB method. Yeah. So in the figure D and E, only GBT and random forest methods obtain the results closest to the main diagonal of the matrix. Consequently, the variables related to true positive and true negative are aligned. Yes, so it is observed that there were minimal examples of false negative in the random forest approach and no false negative sample for the GBT approach. So this is an interesting result, yeah, for the business perspective, making it possible to maintain assets with proper maintenance treatment. The main difference in the false positive, in which the gradient boosted tree approach predicts more than 2 times the problem that do not exist in the field compared to the random forest method. Yeah, this is an increase in the reliability features of prediction of the random forest method, a fact that generates benefits in maintenance activities, minimizing the unproductive displacement of field teams and the costs linked to these activities. And in addition, the forward time of the random forest approach is 40% faster compared to the gradient boost tree, which in large scale predictions could be more favorable to the business areas. So, in conclusion, well, to the best of our knowledge, this paper presents the first application of an ML method to failure prediction in automatic recloser, possibly because of the complexity of the historical data acquisition of the automatic reclosers. On the other hand, the numbers of these assets installed in the smart grids has been increased. Consequently, an automatic and intelligent model to help this monitoring is essential. This analysis of the results obtained from ML methods indicate that some methods were more appropriated than others. The methods based on ensemble F and GBT were the most appropriated in our analysis. These results may have been achieved by the ability of the specialization of each method that compose the ensemble approach. And the future work will focus on more intensive experiments with ensemble methods and be optimized with a balance between speed up performance and F1 score performance. In relation to the data set, other climate features and other sensors will be explored in order to contribute with a more robust result. Also, a larger amount of historical data could be used to check the robustness of the machine learning methods, and other problems related to the sensors will be considered too. So I think that's it. Thank you for your attention, and let me know if you have some questions. Thanks.
Okay, I have some questions. Thank you very much for your excellent presentation. And maybe this is a very simple question. I don't know, because I am really not aware of anything about smart grid maintenance problem. So I guess many in the audience will be in the same position as I am. But what kind of mapping is there between the methods applied and the scenarios of failure? I have no idea about that. And is there any critical attribute in failure prediction, like how fast it is or how accurate it is? I really have no idea, because you present many methods, and I don't know how to map those methods with the problem, let's say.
Yeah, we in the literature review we research these methods, and various papers, article, conference use these methods to failure prediction in others assets of the distribution system. Yeah, so use these methods because the literature review show us that there was the more to apply
okay.
of these problems in assets of the distribution energy system.
Okay, so they are not, those methods are not specific to a kind of problem. Let's say it's a general use.
Yes, it's general,
Okay.
but the literature review show us this. It's fit to these assets of the distribution system. Yeah, so we use and we notice that just two methods, GTB and random forest, is more applying to our problem of predicting failures.
Okay. Well, thank you very much.